Assalamualaikum. My name is Emylia Binti Ahmad Tajuddin. Today my team going to present about wind power generation. So what is wind power generation? Wind power generation consists of process of converting wind energy into electrical energy. With a carefully designed blade, the wind generator captures wind energy and transforms it into mechanical energy, which drives the spinning generator and converts wind energy into electrical energy. A direct-driven wind power generator set and a dual-driven wind power generator set are both commonly used wind power generation systems. A direct-driven wind power generator set is connected to the grid via a full power converter, whereas a dual-driven wind power generator set is connected via a dual-driven converter. Next, this is our background study. First, wind power is a sustainable, renewable energy source that has a substantially lower environmental impact than fossil fuel burning. Due to that reason, wind power generation, in particular offshore wind power, has been the focus of a significant increase in interest in recent years. But grid during peak and valley hours would result in the shutdown and low output activity of the thermal power generation systems during those hours, leading to a rise in the consumption of coal and a major reduction in economic performance. So, conducted this study on wind power generation to learn more about the power generation works and the detail of it for us to overcome this limitation. It has two types of wind turbine, which is horizontal and vertical axis wind turbine. There are some difference between these two types of turbine. In terms of rotating speed and installation cost, the horizontal axis is higher than the vertical axis. The vertical axis has no cable standing problem compared to the horizontal axis. According to the block diagram here, as wind blows over the blades, they lift and revolve, causing the rotor to spin. The rotor will then revolve the low-speed shaft at 30 to 60 rpm. This slow-moving shaft is linked to a gearbox. The gearbox will link to the slow-speed shaft to the high-speed shaft, increasing the rotational speed. The generator is driven by a high-speed shaft. The generator will employ electromagnetic to create electricity from the shaft rotational energy. The anemometer will measure the wind speed and send it to the controller. The controller will operate the machine at wind speed ranging from 8 to 60 miles per hour and shut it down at 55 mph. Pitch control will move the blades away from the wind to regulate the rotor speed and prevent the rotor from rotating in wind that are too high or too low to generate power.
Thank you, Emylia. Good morning, doctor. My name is Kumaran Selvaraja. Today I'll do a presentation on mathematical modeling. So this is the basic working principle in wind turbine energy. As we can see from slide here, kinetic energy from wind change into mechanical energy at turbine blade and then finally change into electrical energy. It says that wind turbine cannot convert 100% electrical energy from wind into mechanical and electrical energy. So from the equation of wind power, we can convert into equation of mechanical power. So in this equation of mechanical power, we have Vu and Vd. Vu is the wind velocity before pass through the wind blade, turbine blades, which has high velocity with more kinetic energy. Then the Vd is the velocity after wind pass through the turbine blade, with lower velocity and less kinetic energy. So basically there are two main calculations included in wind power generation. First is how to calculate the power in wind. Let's say we were given this situation shown above. Then we just insert all the parameters given in the formula we derived earlier, and then we will get the value as shown here. Next, we will see how to calculate the total energy generated by wind turbine in a year. Basically, the capacity of the wind turbine will be around 1.5 to 3 megawatt. Let's say we would like to calculate the energy generated by 2 megawatt turbine with 25% capacity factor. So this is how we calculate the energy generated by multiplying 2 megawatt with 365 days, 24 hours, and finally we will get 25% capacity factor. And then we will get this value shown here. Thank you, doctor. Now I will pass this presentation to my partner.
Thank you, Kumaran. My name is Ryan. I would like to continue the presentation. I'll be talking about the share of electricity production from wind, which means the amount of energy produced from the wind power generation. So firstly, in 2021, we can see the amount of electricity production from wind has increased rapidly from 1985 until 2021. This is because many countries such as Southeast Asia, including Malaysia, has begun shifting away from fossil fuel and has developed more renewable source. Wind power at generation in Turkey and China is higher than the world average power generated because the world taking in global measures, whereas Turkey and China only focus on respective countries. So you can see Turkey is 9.34%, as well as China is 7.68%, which is higher than the world average of 6.54%. Alright, so the next will be the population gets the energy. So this is the world average, the China, Turkey, Vietnam, Japan, etc. The capital per capita, one person will receive how many users, how many watt, and users how many watt, and then the total installed in that particular region or country. So you can see the world average of 104.87 watt of wind power per capita equals to 3 megawatt turbine per 28,686. This amount comes from average of one onshore wind turbine, which actually can provide energy sufficient for 28,606. Nextly, China equals to 3 mega turbine per 23,000 people, and then Turkey equals to 3 mega turbine per 71,000 people, and then Vietnam equals to 3 mega turbine per 84,000 people, and then Japan equals to 3 mega turbine per 81,000 people. India equals to 103,000 people, and then Pakistan equals to 505, which is 500,000, and then Philippines equals to 750,000 people, and our neighboring country Indonesia equals to 300,000 people. Alright. So I'll be talking about the energy mix. Energy mix is the breakdown of various primary energy sources used to meet its energy consumption needs in a given geographical position. Geographical energy. Energy mix can vary according to energy resources available to that country or that region. So it depends on resource available, import resources, as well as the type of energy need to be met. It also depends on policies related to the country's specific features such as economic, geopolitical, historical, environmental, social, and also demography. So I took the data about the primary energy consumption energy mix in the Asia only focus. So we can see actually until up to 2021 last year, 2021, actually wind energy only provide 2,056 terawatt per hour, which is not very huge because most of the country and including our country still rely on coal, oil and gas. So if we put into the chart, in the integrative pie chart, actually wind energy is nearly 2% in the energy mix. So that's all for my presentation. Thank you very much. I would like to pass to Gee Shin Wai.
Thank you, Ryan. My name is Chao Jin Seong. So now I would like to continue the content how the government commitment toward promoting a suitable production of the wind power generation. So as we can see, unlike the renewable energy like solar and hydro energy in Malaysia, wind energy has yet to be approved as a source of the nation's renewable energy. Malaysia's wind speed is low and not more than 2 meters per second, but most of the wind turbines need a minimum speed of 4 meters per second for electrical generation. Some places in Malaysia like coastal area and winter places are suitable for wind power generation such as Kuala Terengganu, Mersing and Kudan. Does the government have any countermeasure against it? In 2017, the former Minister of Energy, Green Energy and Water, Datuk Sri Dr. Maximum said that the government sought to export wind energy to lessen carbon footprint and to reduce greenhouse gas emissions. In 2019, Dr. Tun Mahathir Mohamad also proclaimed that the government has proposed to build wind turbines in the sea and on the east coast of Malaysia. So now, let us compare the three of the power generation already existing in Southeast Asia. For the first one is the Binti wind farm in the Philippines. It is the Southeast Asia first wind farm, and it consists of 20 of those wind turbines, each with maximum production capacity of 1.65 megawatts of electrical power capacity, and total general power is 33 megawatts. And it also provides 50% of electricity, and it has been estimated that 56,000 tons of carbon dioxide is being reduced by the project on a year basis. So the government also announced some policies and mechanisms like Renewable Energy Law of 2008 and Green Energy Option Program. For the next one is the Bac Liu Wind Farm in the Vietnam. This is the biggest wind power project in the Vietnam, and also the first wind project farm in South Asia was built on the continental shelf with 62 turbines on the coast. Each turbine has a capacity of approximately 1.6 megawatt provided by General Electric, and the total generation power is 73.6 megawatt. The gross annual electric output of 335.2 gigawatt per hour and offers 151 kilo of carbon dioxide emissions a year. According to the Vietnam National Power Development Plan, clearly indicates that the government is proximate the development of wind power generation. So finally is the KR1 wind farm in the Thailand. This is the highest capacity wind farm in the Southeast Asia, and it composed of 5 wind turbines and each with 2.3 megawatt capacity, and total generation power is 19 megawatt. It is generate 262 kilowatt megawatt electricity and supply enough clean and energy to power 22,000 household offensive 140,000 of carbon dioxide emissions of a year. In the Thailand, in private sector purpose was built out the project for the 10 megawatt wind power plant to integrate the utilized scale wind power generation with a battery energy storage and system. Okay, that's the presentation. So now I want to pass to the Yong Ting.
Okay, thank you, Jin Seong. Let me introduce myself. My name is Kuan Yong Ting. Now, let's move to the advantage of wind energy. The first one, wind energy is an unlimited, clean, free, and renewable energy source. The next one, we can see wind turbine harnesses energy from the wind into electricity without burning any fossil fuel or causing air pollution. Okay, the next one, it also helps to reduce reliant on the fossil fuels such as coal, petrol, gas, and oil. The next one, the emission of gas, especially carbon dioxide, nitrogen dioxide, and sulfur dioxide, can be reduced for acid rain and global warming. Okay, let us move to the second of the wind turbine. Is expensive to be installed, but it represents a relative low-cost method of micro-renewable electricity generation. The next one, it will also increase the security, the electrician to non-grid connected location and against the price of the electrical. Okay, the wind energy is easily to be integrated in rural, remote area where it's frequently found of high quality wind resource. The next one, okay, wind energy also creating a very good job opportunity for the worker. The statistics has shown that over 120,000 people working in US wind industry across all 50 states. Okay, the next one, wind turbine service technicians has faster growing opportunity than the average for all occupations in US job of the decade. The next one, over the next 5 years, they are offering more career opportunity such as scientists, engineering technician in the wind power generation. Okay, let us move to the disadvantages of wind energy. The first one, wind energy is not considered to be reliable. Why I say so? Next, we can see that causes by inconsistent of the wind itself to produce energy. The next one, the amount of electrical generated by turbine depends on the wind speed and the direction of the wind. The next one, hard to collect the amount of energy at a given time. The city must have an energy reserve in case the wind dies down for a longer period time. Okay, the next disadvantage is noise pollution can cause health problems for the people who live in the proximity of the wind turbine. Okay, there are two types of sound produced by wind turbine: mechanical hums and whooshing sound. Okay, mechanical noise usually produced by moving components, gearbox, generator, electrical, and bearings. The next one, aerodynamic noise is produced by the movement of air over and past the blades of a wind turbine. Okay, now we move to environmental issue. Okay, environmental issue assessment (EIA), particularly related to impact on fish and wildlife, should be considered for receiving federal funding in the US. bursts and that are the within group in normality collision of wind turbine around the world. Okay, the impact of the wind turbine on the bird can be divided into two categories. One is indirect, one is direct impact. Next one, the turbine has sufficient velocity to kill a bird as the mortal area, 90 meter diameter wind turbine is over 6,300 m square and 10 RMP motor speed. The next one, the turbine forced to shut down if they encounter bursts in a critical condition. Thank you.
As a result, we learned that wind power generation transforms wind energy into electrical energy by having the wind generator absorb wind energy with the blade and convert it into mechanical energy, which is then further converted into electrical energy. The blade is the primary component of a wind turbine, followed by the low-speed shaft, gearbox, generator, high-speed shaft, anemometer, controller, and pitch control. Only in dire circumstances is the brake used to mechanically, electrically, or hydraulically stop the rotor. By generating more electricity from the wind, we may potentially depend less on fossil fuel burning at polluting power plants. That's all. Thank you.